we are the Climate Cabinet Campaign Finance Group, and let me introduce our team first. And we are Bhavya, Kaya, and Yangge. And our external mentor is Caleb, our internal mentor is Trevor, and Sarah is our TA. So, what is Climate Cabinet? Climate Cabinet is an organization that seeks to support state and local candidates and policymakers who are committed to climate action by providing them with data-driven insights and information. Climate Cabinet cares because at local and state levels, politics are playing a very crucial role in enacting climate legislations, but often lack sufficient focus and funding. As a result, our Climate Cabinet Finance Tracker project is dedicated to advancing climate policies by collecting, processing, and analyzing data at both local and state levels. So our problem for this quarter is understanding the funding differences in state and local races between fossil fuel entities and clean energy entities. There's a significant gap in available data right now, which is crucial for the Climate Cabinet as it strives for greater transparency and accountability. Given how complex data associated with campaign finance can be, spanning multiple sources, entities, and transactions, we set out to create an infrastructure to help climate cabinets analyze and visualize it in a very simple way. So our main deliverable is an interactive network graph that visualizes these transactions between entities, and Kaya will dive deeper into how this works.
To create the network graph, we needed to get data on state-level campaign finance transactions. The campaign finance data has information on transactions that must legally be reported based on different thresholds in each state. Transaction data is quite nuanced. Transactions are not just donor to candidate, but can also be donor to PAC, donor to party, candidate to candidate, and so on. Due to the complexity of these transactions, we decided to build a network graph rather than a database to record their flow. The previous quarters have worked on aggregating campaign finance data from various states, such as Michigan, Pennsylvania, and others. After aggregating campaign finance data from each state, a transformer is used to standardize the data since each state's campaign finance data has a different schema. Next, in order to classify entities and specifically organizations from the state campaign finance data as neutral, clean energy, or fossil fuel, we required a pipeline that confidently classifies companies and the industries they are involved in. In order to achieve this, we collect and transform organization data with known industry classifications. We are currently using data from Fossil Free Funds, which provides a list of fossil fuel companies based on their Morningstar industry classifications. Additionally, we are using Infogroup data that has information on U.S. businesses along with their SIC code, which is a 6-digit code that indicates their industry. We transform the data by merging several Fossil Free Funds datasets that list oil companies and coal companies currently. Additionally, we subset the Infogroup data based on relevant SIC codes pertaining to fossil fuel and clean energy. New datasets can be integrated into this pipeline and merged as well after proper cleaning and transformation. Afterwards, we combine the Fossil Free Funds and relevant Infogroup data into one dataset that is cleaned and transformed into consistent data formatting with unique identifiers. Though the Fossil Free Funds data has stock symbols, we've been experiencing difficulties retrieving stock symbols of the Infogroup data based on their name. We attempted to use the Yahoo Finance API to accomplish this, but it cannot retrieve the correct stock ticker symbol for messy names in our dataset. A method that implements entity identification can be developed in the future to help resolve this issue, and stock symbol can be used to improve record linkage. After the company classification datasets are merged, we perform record linkage to both clean this classified company dataset, as well as to match classified companies to our campaign finance dataset. Record linkage is a method that allows us to group duplicate entities, and in our case companies, which may have arisen due to data entry error or the merging of multiple datasets. The figure depicts an example of record linkage where there are multiple entries in the dataset for both Lucas Smith and David Jones. The values for date of birth and city that are associated with these names are quite similar. Thus, it is likely that these rows actually represent the same person and the duplicate rows can be removed. We accomplish record linkage using the Splink package, which is a package for probabilistic record matching that predicts which rows match with each other. It also enables matching between different datasets based on common columns. At performing linkage on individual datasets, we also use record linkage to match entities from the election results and organizations table to our state campaign finance data. Next, we loop in election results data to identify how campaign funds and their flow may end up influencing election outcomes.
As we have established linkages between entities and individuals based on the campaign finance data, our goal is to understand the extent to which funding influences election results. So we have introduced a new dataset covering legislative general election returns from all 50 states, focusing specifically on the years 2014 to 2016 to align with our campaign finance dataset. To integrate this new dataset within our existing schema, we first transformed and cleaned it. And as the transformed datasets from last quarter were not uniform enough, we also improved the existing codes and functions. Finally, we have developed the pipeline that makes record linkage to match between the campaign finance and election datasets. And I'll hand it off to Bhavya to explain the visualization.
Essentially, we create a network graph visualization of these transactions and the flow of funds from entities to campaigns. With the network graph visualizations, we approach the problem by trying to identify what would be the best way to analyze complex transactions. How is it that we can communicate detailed information about their flows and their nature? So the way to think about the network visualizations is through two views. A micro-level view, which is more of a zoomed-in view of transactions, focusing on transactions between specific entities, and a macro-level view, which is more zoomed out, looks into the clusters prevalent and emphasizes on the overall structure and spread of the network. Through each of these two views, there are a series of questions that we aim to answer. With the micro-level view, firstly, we want to know who are the major donors and recipients, what are the characteristics of transactions between the specific entities, how are these entities related to each other, and exactly how is it that contributions flow within different sectors, for example, from fossil fuel to clean energy or vice versa. With the macro-level view, we also aim to understand what are the major clusters within the network, how centralized is the network, are there any identifiable patterns of influence among different types of entities, and how do the interactions between different classification of entities compare with each other. This is a sample of the micro-level view visualization. This is a static image of what would be an interactive macro-level view of the network graph indicating campaign contributions from 2018 to 2023. The sample graph shows the directed flow of campaign contributions to sample entity Felicia Brabeck for state representative from the 2018-2023 data sample. Each node represents the entity, company, or individual involved in the transaction, while each directed edge represents the direction of flow as well as the size of the transaction. The color of the node represents the classification of the transaction, which is neutral in this example case, hence all the nodes are colored green. Here is a sample of the macro-level view. This is a static image of the macro-level view of the network graph indicating campaign contributions in the same time period, 2018 to 2023, where we saw the micro-level view. And we use something called the betweenness metric to map out the clusters here. Betweenness essentially measures the extent to which a node lies on paths between other nodes. Nodes with high betweenness may have considerable influence within a network by virtue of their control over information passing between other nodes. That is, potentially signifying closely tied entities. So groups with common interest or transaction types tend to have higher betweenness. Similarly, the longer edges here reflect the relationships between the distinct clusters being formed. And the shorter edges seem to be indicative of relatively independent clusters. So towards the right of the plot, you'd see one of these independent clusters, while three of somewhat of the linked clusters can be found at the top, the bottom, and the left edges of the graph. Having worked on setting up the data aggregation, processing, and analysis infrastructure and creating the visualizations, some of the processes we undertook revealed insights in terms of the future direction of this project. So firstly, regarding the data aggregation step, our dataset only extends up to 2016 and covers records for a little over 400 candidates from the campaign finance dataset. To enhance our analysis and to increase the number of potential matches, we plan to collect more comprehensive and recent data directly from state websites for this step. Secondly, for the classification step, currently within our pipeline, we have the infrastructure to confidently classify companies, but not organizations such as the PACs, which are included in the transactions dataset. The future work can be directed towards focusing on automating the process of classifying PACs according to the 3 fossil fuel, clean energy, or neutral classifications that we have. And lastly, for the visualization output step, in the future, we would like to customize the appearance of the nodes and edges based on additional information, such as node size based on size of entity, such as for donor companies, or even other metrics that can be computed, such as sortivity or density. Additionally, we would also consider deploying community detection algorithms or some kind of temporal analysis to observe exactly how connections and clusters evolve over time or different election time periods to improve the analytical depth here. In conclusion, our analysis will help Climate Cabinet support its mission of data-driven climate legislation. Climate Cabinet can use the results of our network graph and data visualization analysis in their fundraising pitches, or they can post the results of our analysis to attract media attention and raise awareness for political campaigns, which could be funded from fossil fuel versus clean energy entities. And lastly, Climate Cabinet can use this analysis to develop a strategy to target campaign races that would benefit from a more critical analysis of funding sources. And with that, we wrap up our presentation. Thank you for listening.